Good morning, students. Let us start the module 3 of information theory and coding. From today, I will be starting module 3. Before exactly starting module 3, I want to show you a block diagram of the digital communication system, because ultimately the usage of all the concepts which we discuss in information theory are finally going to be implemented in the digital communication system. So you can see here the basic block diagram of a digital communication system, and I feel that the complete block diagram which I am showing you here is not available specifically in any textbook. What I have done is I have referred to many textbooks, and ultimately from whichever textbook I obtained these diagrams, I put all of them in one place. In fact, this diagram I prepared when I was in the industry itself, where I was involved in the training of the engineering graduates for the wireless communication systems. So, this I did not prepare for the sake of ITC. This I had prepared many years before for the industrial training purpose. So, let me briefly discuss about this block diagram, which is really very important. We have an information source, and we assume that our information source is completely digital. If at all the information source is analog, then you should have one ADC here. But ADC is not going to be shown here as such, because we are dealing with the information theory, and in information theory we deal with only digital sources as such. So we have an information source. Later on we have a block called formatting. Then we have a block called source encoder. Then we have a block called encryption. Then we have a block called channel encoder. Then we have a block called multiplexer. Then we have a block called multiple access. Then we have a block called spreading. Then we have a block called modulator. Then we have a block called amplifier. Later on it is connected to the antenna. Here I am predominantly discussing the wireless communication system. That is why I have shown you an antenna here. Otherwise this can be a wired channel as well. Later on I am going to show the points about the functionalities of each and every block here. But we have been discussing this source encoder till now. Now from now on we are going to discuss the channel encoder. And you already know about the information source as such. What is meant by formatting, let me tell you a little bit later. And what is meant by encryption, let me tell you a little bit later. But let me tell about these other 4 or 5 blocks now itself. Okay. You already know about what is meant by encryption. You may not be familiar with the term called formatting, but encryption you already know. Encryption and decryption are common processes nowadays in every communication system. For example, nowadays even WhatsApp messages are going to be encrypted, which means there should not be unauthorized access or unauthorized hacking or some other thing. So what they do is, for the message they will add some other secret key in such a way that at the receiving side the same secret key is going to be used to decrypt the message, so that in between it is a public channel. Whether it is a wired channel or a wireless channel, it is going to be a public channel. And in fact wireless channel is more prone to hacking when compared to wired channel. The wired channel will have a dedicated medium for communication, whereas wireless channel is the open space itself, where anybody can tap into any signal and anybody can decrypt the information as such. I had seen a Tamil movie many years before. I don't exactly remember the title of the movie, but that movie hero was Kamal Hassan himself. And in that movie, Kamal Hassan was going against some of the government's policies, where government was doing some drastically wrong things. Now he wanted to make the public aware of the things which the government is doing. So what Kamal Hassan did was, in his van, he had a transponder unit itself, transmitter as well as receiver, transceiver unit itself. And he used to pick up the local TV station's RF carrier, and using that RF carrier, he used to transmit his message. And in the television, whatever Kamal Hassan was discussing was broadcast instead of whatever the television channel was broadcasting. It was possible because it was a wireless channel and he could tap into that RF carrier. he could use the same RF carrier for superimposing his message instead of the regular broadcast message. That is possible using technology. That way wireless channel is more prone to such attacks. So encryption becomes very much necessary, where the message being sent from the information source has to be accessible only to the authorized people. That's the purpose of encryption. Even in your SIM card, there are encrypting algorithms. Okay, everywhere. Nowadays, in every digital communication system, there are encrypting and decrypting algorithms. Maybe in future, when you come to final year, if you opt for the course called Network Security and Cryptography, you will learn more about the methods of encryption and decryption. Let me come to the channel encoder now. Source encoder is going to reduce the redundancy, whereas channel encoder is going to introduce a planned redundancy so that at the receiver the error can be detected and the detected error can be corrected. So from now on, from module 3 onwards, we are going to focus more on channel encoding techniques. After the channel encoder, now you can see right from the information source till the channel encoder, it is in the binary stream. Data is basically in the binary stream. Now what is multiplexing? Multiplexing means using a single channel for many other information transmission. For example, video and audio data can be together multiplexed and it can be channeled, or through the channel it can be transmitted. There are many methods of multiplexing called time division multiplexing, space division multiplexing, frequency division multiplexing, and so on. So the purpose of multiplexing is to use a single channel for sending multiple signals, such that we are going to save the resources, we are going to reduce the cost of the transmission. That is how audio and video will be together transmitted through the multiplexing techniques. What is meant by multiple access? Multiple access means multiplexing is basically for a single user. For example, let us say you and me are having this online class now. Now in the online class, the slide is also going to be transmitted to you and my voice is also going to be transmitted to you, which means audio and video are together coming to you. Now this is a method of multiplexing. But now, what is multiple access? Right now, I am transmitting signal from my side, whereas many students are accessing the same system, right? It is a single teacher talking to so many students. That means what is it? It is multiple access. In the sense, multiplexing is only for a single information transmission, both for audio and video, let us say, or both for audio, video, text, music, data, voice, whatever way. Multiplexing is to pack large amount of different types of information into a single channel, whereas multiple access is that particular channel can be accessed by multiple users. So in multiple access, again we have techniques called FDMA, frequency division multiple access, TDMA, time division multiple access, CDMA, code division multiple access. You are going to study more about the multiple access methodologies in the next semester when you study digital communication, again in the 7th semester when you study wireless communications. Okay, so multiple access means a single channel can be accessed by many users. For example, we are all using this free space for communication. Now the free space can be accessed by so many cellular service providers. The free space is also utilized by television broadcasting companies. The free space is also utilized by FM radio broadcasting companies. And the free space is also used by military service for radar applications and for spatial transmission, even for GPS. See, this space is accessed by multiple users or multiple systems that way. It is possible by means of an allocation of frequency or an allocation of a time slot or an allocation of a code. These are all beautiful techniques which were developed in the last few decades. In fact, it is because of CDMA that now we have 3G and now we have 4G. In future, we will have 5G Basically because of a very innovative method called code division multiple access, where frequency can be same, time can be same, but for each user a specific code will be allocated. Just to give an example, let us say we have an offline class and I am going to call your attendance. When I call your attendance, the same frequency is going to all the students. My voice frequency is going to all the students and it is going at the same time, but only one of them will be answering to my attendance. All others also will be listening to my voice, but they will not be answering present sir. They will not be answering it is not my name also. You will be remaining silent until your name is called, but you will be receiving all the names which I am going to call. That way, in your head you have the name. That name is your identification code. When that name is transmitted from my side, you are going to identify yourself with that particular name, then you are going to respond. That is nothing but CDMA, code division multiple access. So at the same time, using the same frequencies, multiple people can access the network system, which is a very innovative and highly useful technology. Now because of CDMA only, now we have 3G and 4G, in future we will have 5G. All are based on CDMA technology itself. Otherwise earlier in 0G and 1G we had a FDMA, and in 2G in GSM we had TDMA. Now also TDMA is there along with FDMA. On top of that there is CDMA, which is much more complicated spectrum now. That means all the three multiple access methodologies can be combined together to have a higher level data transmission. That is how from kbps we have come to mbps. Now we are moving on to gbps. In future we will be moving on to tbps. From kilobits we have moved to megabits. Now we are working with gigabits. In future it can be terabits. All is because of the usage of multiple access techniques. Next, coming to spreading. What is basically spreading? You will be studying more about spreading in the subject again, digital communication, where you have a spread spectrum technology. That means the signal will be spread as a wideband output from your system, and the spread spectrum will have access to so many people, and whoever is matching with their particular code, they will access this particular spectrum which is spread. Spreading is basically outputting or outpouring the information in a larger bandwidth so that many people will access. That is spreading. You will study more about spreading in future. Next we have modulator. See, till spreading, the information remains in the digital form itself, in the binary form itself. All the upper four blocks are going to process the information in the binary form only. Please remember that. But the binary signal cannot travel in free space. A square wave cannot travel in free space because the square wave will be subjected to attenuation in free space. So always a sinusoidal carrier is going to have a easier propagation in free space, not a sine wave. Sorry, not a square wave. Which means the carrier wave should not have abrupt changes from 0 to 1 or 1 to 0. A carrier wave cannot be a square wave. Even if a square wave is output into the free space, due to the characteristics of the free space, it is going to become a sine wave there. You will be learning more about this spatial characteristics and about impedance matching and all those things in the course called Microwaves and Radar. Okay, you will be studying more about the properties of microwaves there. You will be learning about a distributed network, distributed model and lumped model and all those things. Of course, discussion of those things is beyond my course as such. So let me limit myself to discussing only the information theory. So till spreading, it is digital signal. Now the digital signal cannot be output into free space because there are propagation issues with the square wave in the free space. Whereas the sine wave, we can easily move. Just visualize the snake moving. When the snake is moving, it is moving in the form of a sine wave. It is not moving in the form of a square wave. Now, just for the sake of a humor or fun, Visualize the snake moving as a square wave. Can it really move effortlessly? If the snake is going to move as a square wave, it has to distinctly have a 90-degree turns. When it has to distinctly have a 90-degree turns, snake is going to put a lot more effort for its movement. And moreover, such distinct 90-degree turns are not going to be useful for its movement in any way. Time will be delayed there, or more time will be utilized by the snake for its movement. That is why God made the snake to move only in that particular fashion of sine wave itself. In fact, whatever human beings are doing is nothing but replication of nature only. All these engineering or technologies or whatever we boast about or we talk about or we are proud about, seriously speaking, we are observing nature as such, and whatever is already there in nature, that only is going to be implemented in the technology. Nothing else. Human beings are not creating something new as such. They are only understanding the hidden secrets of nature, and they are implementing the hidden secrets of nature using these methodologies. Otherwise, we may keep boasting that we are in the VLSI domain and we are making microchips and using silicon as a semiconductor. We are manufacturing integrated circuits, and we can boast about our own 3G, 4G, 5G technologies, or we can boast about developing mobile phones, developing laptops, developing desktops, all types of electronic gadgets, televisions, radio systems. We can boast about all that. But the fundamental point remains the same. The fundamental point is, who manufactured silicon as semiconductor? We define silicon as semiconductor always. But the first point is, silicon in nature is manufactured as semiconductor. So we should frankly admit one fact, that God made silicon as semiconductor. Then we are using silicon for our purposes. If we can frankly admit this particular fact, then we can really understand nature or universe in a different angle as such. So, why I am telling all these things is because human beings or technocrats or engineers or scientists need not be proud or need not be arrogant or need not be egoistic, saying that they have invented something new. They can honestly say that they have discovered something new. Discovery is something different. Invention is something different. Invention cannot be possible that way because all these are already present in nature. For example, electromagnetic field is already present in nature. Gravitational force is already present in nature. Now, we cannot say that Newton invented the laws of gravity. We can only say that Newton discovered the laws of gravity. For that matter, precisely we cannot say that anything an invention. Precisely we can only say that anything is a discovery. Already such things are working in nature and we are using them for our purposes. That's all. Let me stop my philosophical discussion. Let me come back to technical discussion now. So, till spreading, all these things are basically what? Basically binary information. Now, the binary wave cannot be transmitted into free space because of the reasons as I have told you. It is better to convert this digital information into a sinusoidal form and then gradually project this sine wave into the free space. Or even if it is a wired channel, it is better to project this sine wave into the wired channel. That is when after spreading, we use a modulator. Now, what is the modulator going to do is, the modulator is going to superimpose the binary waveform into a sinusoidal carrier waveform. The carrier is going to carry the binary information signal. In general, the modulator is an analog carrier signal which is of a higher frequency when compared to the digital signal. So here the digital signal which is coming out of this spreading block is going to be a modulating signal, and with the modulator we will have something called VCO, voltage controlled oscillator. That oscillator will be working with a much larger frequency. Now that frequency is called as a carrier frequency. That is going to carry the information signal or the modulating signal. Now the output of the modulator will have carrier as well as information together. the information superimposed on carrier wave. You are going to learn about different modulation techniques such as amplitude shift keying, frequency shift keying, phase shift keying, quadrature amplitude modulation, and all those methods you are going to study in the next semester. So later on, after the modulator, we should have an amplifier, because the free space will have attenuation and the free space will suffer from noises. The free space will have interference from other signals, and the free space itself will have its own phase shifting characteristics. Free space will have enough of its own issues. Now, in spite of all these issues of the free space, the signal has to reach till the destination. If the signal has to reach till the destination, the signal should have enough power for it to be transmitted effectively, for which at the end we will have an amplifier. Please remember, this amplifier is not an audio amplifier. This amplifier is a radio amplifier. Designing an amplifier in the radio frequency band is a challenge. You would have worked with amplifiers in the AEC lab when you actually connected a BJT or a JFET and you connected resistors as biasing components, and you would have measured the gain and bandwidth for a single stage amplifier. Or you would have done a multi-stage amplifier simulation also using PSpice. But you used audio frequency amplification there. Now what we are talking about is radio frequency amplification. For example, if your cell phone is using 2.4 gigahertz as a carrier wave, now in the cell phone you should have an amplifier which is working with 2.4 gigahertz. You will be simulating some amplifier circuits for a radio frequency range in the VLSI lab. There you will understand more about the limitations of the amplifiers there. So please remember, designing an amplifier in the radio frequency range is a challenge, and that is where electronics engineers are required in the VLSI domain, both in the analog side and both in the digital side. Now after the amplifier we have an antenna. Now the output which is coming from the amplifier is completely in the radio frequency form along with the information content present. Now this has to be projected into free space through an antenna. What is an antenna? Antenna is an open transmission line. You can see that right from the information source till antenna, it is a single wire there. And there is the other wire there. Other wire is the ground wire itself. Always if a signal is moving, the signal is with reference to a ground reference, right? Any electrical signal is always moving from the source and it is going back to the source actually. For example, in a circuit diagram, if you connect a power supply, from the power supply's positive terminal, conventionally we measure the current going into the circuit, and ultimately the current is going back to the negative terminal of the battery or power supply itself, which means energy is moving from the source back to the source. Energy always tries to go back to its own source. That is the basic property of energy. Just visualize the ocean water getting evaporated because of the sunlight or sun's heat, and gradually it is going up and becoming clouds, and the clouds are going to condense themselves and pouring water down on the earth's surface, and that water falls on the surface of the earth, and that is going to fill into the ponds and the rivers, and the rivers are again flowing back to join into the ocean, which means the water from the ocean itself is going back to the ocean. That is when you please remember that the energy always tries to go back to its own source. Now when it is going back to its own source, it will find a least resistant path to go back to its own source. Now when there is no path available, what it will do? That is the point here. See, information source is going to emit the symbols, and then onwards it is coming all the way till the amplifier, and this is the least resistant path, which is an electrical wire. Now abruptly the signal finds that the electrical wire is ending, and it is resulting in a metallic structure now. Now it has to go out because there is an electrical pressure to go out. When it has to go out, it is not finding a path. When it is not finding a path, the electrical signal will transform itself into an electromagnetic signal. Why? The reason is space is magnetic. The free space around the antenna is basically magnetic. Inside the electrical appliance, it is electrical wire. But outside, there is no electrical wire. Wire is abruptly ending and it is terminated with the antenna structure. Now the signal has no other choice than to transform itself into whatever is matching to the free space. Now the free space is the channel and the antenna's characteristics has to match the characteristics of the free space. Otherwise, antenna is simply a metallic termination. Antenna is simply an open transmission line. The antenna is not an active device. The antenna is a passive device. And the antenna is not going to do anything as such. It is a signal which is going to transform itself into the form through which it can match into the channel. That's all. Otherwise, many people think that antenna is transmitting, antenna is receiving. No. Antenna is not an active device at all. Inside an antenna, you will have only a metallic shape. Inside your mobile phone, you will have a metallic patch that is called as patch antenna. That metallic patch itself is going to absorb the electromagnetic signal. Actually, it is the electromagnetic signal which is being radiated into free space because of the electrical pressure. It is not that the antenna is converting the electric signal into the electromagnetic signal. Antenna is an open transmission line and the signal will convert itself into electromagnetic form because it wants to go back through the nearest or the least resistant path and it wants to go back to the source. Now it is not finding the source. Imagine the signal is blind. The signal does not have any sense organs. The signal does not know where is the source. The source is actually the information source here itself. But the signal does not know where is the source. Signal wants to go back to the source. But it is finding that there is no wire now. There is no connection now. Now signal has to transform itself to go back to the source. If at all I have to give you a live example for this, I am speaking through my mouth. Now from my mouth voice is coming out. The same voice will be coming back to my ears. When the voice is coming back to my ears, then only I will be hearing to my own voice. When I hear my own voice, I will be prompted to speak to you. Strictly speaking, the voice which is coming out of my throat does not know that it is going to your ears. Actually, it is going back to its own source. It is coming back to my own ears. And part of the signal is spread now. When the part of the signal is spread now, the microphone picks it up and it is converted into a radio frequency through my laptop and it is communicated to you all the way. Otherwise, my voice is coming back to my own ears. Energy always tries to go back to its own source. If I don't listen to my own voice, then I will not be able to speak at all. My dear students, watch a particular movie called Children of a Lesser God. Very beautiful movie, Oscar award winning movie, Children of a Lesser God, where the hero trains the deaf and dumb people to speak. Basically, the deaf and dumb people are not dumb. They are only deaf. They remain dumb because they will not know how to use the vocal cords at all. Otherwise, their vocal cords, their tongue, their teeth, their mouth, they are all working as such. Only thing is, whatever voice is coming out of their own throat, they are unable to listen. Because of which, they will not learn how to speak. And because of which, they cannot speak. Now, the deaf and dumb people can be trained to speak. Only thing is, they may not be able to listen to their own speech. But others are able to listen to the speech, right? That is what is the story of that particular movie, Children of a Lesser God. Very beautiful movie. You people have to watch such movies to understand more about human body, more about energy, and more about communication also. So that way, energy is trying to go back to its own source, means my voice is trying to go back to its own source through my own ears. When I listen to my own voice, only then I will be prompted to speak more. But in effect, part of that energy is picked up by the microphone, and that is going to be transmitted to you as my students. So let me come back. Again, I am going back to philosophy. Let me come back to technology. Let me reiterate or stress that antenna is an open transmission line. Antenna is not intelligent. It is the energy that is intelligent. Energy is transforming itself. It is not that antenna is doing anything great. Antenna is simply an open transmission line. It is simply an open wire. It is simply an open metallic surface. It is not an active device. It is basically a passive device. Please remember this. Otherwise, many times when I ask questions to students about the functioning of antenna, they keep on saying that antenna is doing something great. No, it is the energy that is doing something great by transforming itself. You already know the property of the energy, that energy can be converted from one form to another. Energy can never be created nor be destroyed. The same thing is holding good now in the communication system as well. With this brief introduction about the working of the digital communication system, now let me proceed for the brief explanation of this block, where I have that in my next slides. In between, if you have any questions, you can unmute and ask me, or if you are hesitant to unmute yourself, you can put it in the chat box also. There are still another 10 minutes. Whatever I had discussed till now, in this, if you have any doubts or queries, feel free to ask me. Otherwise, I will proceed with my next slide now. Anyhow, hardly 20 students are listening to me. Other 40 plus students, and there is section D also. All those students are comfortably silent. Anyway, that is the ratio which I have to expect now. Let me not demotivate the listeners by thinking about the non-listeners, right? At least 20 students are listening to me. I should think that I am fortunate and you are fortunate. Let me go to my next slide. Formatting transforms the information into digital symbols. We had an information source. Now the information source need not be necessarily digital as such, because we had telegraph systems, we had teleprinter systems, we had many other Morse code systems earlier. Now all of them need not be essentially digital symbols. Now, but when it comes to the source encoder will take only symbols as the inputs. So there is another block here called formatting, which will transform the information which is coming from the information source into digital symbols as such. Otherwise, information source is basically digital. It may not give out symbols. It may give out alphabets or characters as such. Please remember that symbols are slightly different from characters or alphabets. Please revise the basics now. So we require a block called formatting. On the other hand, if the information source itself is able to transmit symbols on its own, then the formatting block is not necessary as such. Next point is source coding eliminates redundancy. This we have seen, and we have seen three methods of source coding called as Shannon encoding, then Shannon-Fano encoding, then Huffman encoding. We have already worked out these three coding techniques. Now these coding techniques are going to eliminate the redundancy. That means there is going to be the information packing by means of a concept of entropy, where we will optimize the number of bits that are going to be transmitted so that the information is not lost, but the number of bits are reduced. That is called eliminating the redundancy. Now encryption is also called as scrambling sometimes. Encryption or scrambling is performed to maintain privacy and security. This I have told you already. Next, channel coding is performed for error control. Means channel coding is going to introduce additional binary digits or additional bits, which are specifically meant for error detection and error correction. Which means channel coding is basically for error control. Error control is nothing but at the Receiving side, it has to detect the errors which are present in the received signal, and it has to correct the errors. That is called error control. For that purpose, the transmitter itself has to have a methodology of introducing additional bits. Multiplexing process combines the signals from different information sources. This I have told you. If there are video sources, audio sources, textual sources, music sources, or voice sources, or data sources as well, all of them can be combined into a single channel. For example, when you are watching a movie in a film theater, you will have audio and video signals together there, but they are projected as a single channel there. Similarly, when you are playing a DVD movie, then from the DVD movie, audio and video are stored separately, but they are taken together and they are given into the DVD player, and the DVD player processes them together. That is basically multiplexing. Multiple access allows different users to share the same communication resource. This I have told you. Multiplexing is different, multiple access is different. Multiplexing is a single channel which is containing different types of information, whereas multiple access means multiple users use the same free space or same communication resource for their communication purpose. For example, let us say you come to a MG Road, Brigade Road junction, which is a very popular junction in Bengaluru city, for the youngsters especially. Whoever comes to Bengaluru city will always visit the MG Road, Brigade Road junction as such. Okay, they may not visit the Vishwesvaraya Museum, which is also nearby there. Okay, they may not visit at all the Venkatappa Art Gallery, which is also nearby there. But people will definitely visit MG Road and Brigade Road junction. You may ask me, sir, how do you know? I also did the same thing when I came to Bengaluru. My friends told me, first visit MG Road, Brigade Road junction, that too in the evening time. So I used to go there. Now definitely you people, when you come back to Bengaluru, you will definitely visit MG Road and Brigade Road junction. If at all, the lockdown is lifted and again people will start moving around. Now why I am mentioning that MG Road and Brigade Road junction? Many people come there in the evening time, and there are hotspots installed there, Wi-Fi hotspots installed there, because many people who come there, even foreigners come there, tourists come there. When they come there, they want to have a seamless connectivity for the communication channel. They want a Wi-Fi hotspot. For that matter, all the 5-star hotels are going to have, are already having hotspot Wi-Fi everywhere. Even in our campus, we have Wi-Fi hotspot, right? Which means what? We want our students to have a Wi-Fi connectivity always. Similarly, in the 5-star hotels, they want to have Wi-Fi connectivity for all the customers. Those are called hotspots now. If you are nearer to a hotspot, which is used as a Wi-Fi transceiver, now multiple users are going to use the same hotspot at that time. It is a single Wi-Fi transceiver where multiple people will be accessing it. That is called multiple access, where different users share the same communication resource. Lastly, spreading process combats the effects of interference in free space. I am not going to talk about spreading now. You will learn about it more in the next semester. I have already told you about a method called spread spectrum. There are methods called FHSS, frequency hopping spread spectrum. You will learn more about it in the next semester only. But this is going to combat the effects of interference in free space. Because in the free space, each one will be interfering the other signal, right? Let us say in the Wi-Fi hotspot, there are now 50 people. Each person will be interfering with the other person's signal as such. So that way, in spite of the interference, you should have communication. Just to give a live example, imagine there are 60 students in an offline class, and imagine there a teacher is shouting to these 60 students. Not shouting, maybe lecturing. Now when all 60 students keep talking to each other, now the teacher has to shout so as to amplify the signal so that the signal will reach to the class. Otherwise students may not stop talking. Now when students are also talking, at the same time teacher has to raise the voice and teacher's signal has to reach to all the students. That means each student is interfering with the other signal, right? When all students are talking inside the class, each student is interfering with someone else's signal. In spite of all that, the teacher's signal has to reach. So, without amplifying, how can we combat the effect of interference? That is a method called spreading. If spreading is not there, then the amplifier has to be utilized with a large amount of power. But as I have told you, designing an amplifier in the RF domain is going to cost a lot. Moreover, the gain in the radio frequency domain is going to cost more. An audio amplifier's gain is easier to achieve. A radio amplifier's gain is not so easy to achieve, and there is a cost involved there. Battery will drain faster if at all we go for a larger amplification of the radio signal. That is where spreading is going to help. Later on, we have something called modulation, which converts the symbols into the corresponding waveforms. Remember this concept. The digital waveform is going to be converted into an analog counterpart. That is why symbols are converted into waveforms. Until modulator, it is completely digital. After modulation, it is going to become analog. Finally, the amplifier raises the power content of the signal so that the signal will reach to the destination. Now, the gain of the amplifier depends on the distance between the transmitter and the receiver. For example, between the base station and the mobile phone, the maximum distance can be 1.5 to 2 kilometers, especially in the urban area. In the rural area, it can be up to 5 kilometers also, because in the rural area, there is less interference and the signal can propagate easily in the rural areas. But in the urban area, we have buildings, we have obstructions, and we have other interferences from the other signal sources, from the other cellular service providers. So there we require at least maximum, not at least, maximum 2 kilometers between the base station and the mobile phone. Now in such a case, the amplifier will be designed in such a way that from your mobile phone, it will reach at least up to 2 kilometers to reach to the nearest base station. There need not be a larger gain than that, because the distance is fixed as 2 kilometers. The amplifier has to be designed so that the signal will be received at the base station. That way they design an amplifier based on the particular application. Now with this introduction of the digital communications block diagram, I am ending today's class. In the next class, I will fully start with my third module. Until then, take care and goodbye.